Yeah, this is still the 2016 paper, question 3A. So they've given us the integration by parts formula, which is something like, they gave you this. Say that the integration of two functions multiplied together, we're going to say, this thing is, they give you this integration by parts formula is that when you have an integration of two functions multiplied together, you're gonna say that the first function is the original function and the second function is a derivative of another function, and then you're going to integrate that second function to you're going to integrate that function, the second function, then you're going to do this, you're going to times the first function by the by the integration of the second function, then minus the integration of the derivative of the first function times the integration of the second function. Well, it's a bit complicated, but I'll show you. Alright, so for this question, a function where x is a real number is defined implicitly by the following formula. They want us to find the explicit expression for a function in its simplest form. Okay. So what they want us to do is just to integrate this part, right? So we can just find the explicit expression for this, for this. So by looking at this equation, we can see that this part and this part is the same, right? And we also know that this is going to be a number, right? This is going to be a number because once we integrate something and we're going to evaluate it, it's definitely going to have a value. So that's not going to change, right? It's not going to change because it's a constant because it's the integration of something and we have to evaluate that. So it's a constant. Okay, so what we can do is we can say that fx equals to x minus a, right? We can say that this part, this part is a constant. So what we're saying here is we're saying that the integration of function fx sine x is a. So what is function? So what is fx? We just said that fx is x minus a, right? And this makes it much easier because then we can use the integration by parts formula they've given us. So now we can do correct. Well, I'm just going to ignore this part. I'm just going to keep going on with this part. Yeah, and then we've got this, okay? And now we can use the integration by parts formula because we have two functions here. And what we're doing now is we're going to find the f and g's. Okay, I would go, so let's say I would put the easier ones as the f and the I'll put the G. Yeah, probably the easier one with G and the more difficult one with F. I'd say in this case, I'm just gonna say G dash is sine x, and F is x minus a. Right, so then F dash is going to be 1, because that's the derivative of F. And then G is going to be minus cos x, because the derivative of cos x is minus sine x. So the derivative of minus cos x is going to be positive sine x. Okay, so now we've got this, we can just substitute this thing here. And I'm just gonna drag this over here. Okay, right. So integration by parts. So we've got F and G. Okay, we cite that G dash is sine x and F is x minus a. So look at this. F times G. Then we're going to evaluate based on the values on the integral. Okay. So that's going to be x minus a times minus cos x. Correct? Then, yep, these two values, then minus f dash is 1, just ignore it. Then g dash is sine x, so that's just sine x. Right, sorry. It's not g dash, it's g. Okay. So, yeah, now we're just evaluating this now. Actually, before that, I'm just going to differentiate this, integrate this thing here. It's going to be, it's going to be minus sine x, okay, yeah, because, yeah, the derivative of minus sine x is minus cos x. Okay, so now what we're going to do is, I'm just going to write it under the right side. So when we evaluate this, we're going to substitute the values of the one on the top first, and minus this thing after the substitution of the second value. Well, I'll show you. Okay, so now we've got, I'll just put this in brackets. So we've got pi over 2 minus a times minus cos pi over 2. Oh, sorry. Minus 0 minus a times minus cos 0. Done. Okay, the next one is minus sine pi over 2 minus sine 0. Okay, done. So now we've got right, we're just gonna simplify this. Minus cos pi over 2 is 0, so this is gone. And this part's gone. Then minus 0 minus a, so that's just going to be minus a and minus a times the negative, well, minus a then with another negative sign, so that's positive a, okay? A times negative cos 0. A times negative cos 0. Cos 0 is 1. So a times negative cos 0 is minus 1. So which means this is going to be minus a. Right? Minus. So minus sine pi over 2. Sine pi over 2 is 1. So that's going to be minus 1. Then minus sine 0. So that's just 0. Okay, right, sorry. And this is going to be just 1 minus a. And remember, this 1 minus a equals to, equals to this. Remember? That's what we've got from here. So which means what? We're finding the explicit expression for fx. So fx equals to x minus 1 minus 1 minus x minus, in the bracket 1 minus a. Okay. So and we also know that fx is x minus a, right? We said that's x minus a. Oh, sorry, not that. We said that's x minus a. So x minus a equals to x minus 1 plus a, which means minus a equals to a minus 1. So 2a minus 1 is 0, and a is a half. So remember, we said fx equals to x minus a, so fx is x minus a half. Yeah, that's done. Basically just looked at how we solve it by saying this is a constant, and then we said that after integrating this, we've got the number, and add x minus that number equals to x minus a. Yeah, that's kind of what it is. Right. Thank you.